Okay, students. So this is the home screen for Design Expert software. I'm having an older version. You can download your newer version from internet if you want to try. Now, in this Design Expert, you need to first construct a design. So first you need to go to the File menu, and from File menu, you will find an option of New Design. So click on the New Design. Now, there are different options like factorial designs, that is two level, irregular, general, de-optimal, packet Burman, as we have discussed for the screening, then Teguchi design, etc. etc. Then response surface designs, in which there are center composite designs, box blanket designs, three level factorial designs, etc. Then mixture designs like simplex lattice, simplex centroid, de-optimal, etc. And cross designs, de-optimal, crossed, and the user defined. Okay, so all are these designs which we can study. Let us start with the factorial designs, in which or response surface design. Let us construct a response surface design. So we are constructing a central composite design. For an example, in which we have three factors. Okay. Now the factors can be of two types, numeric and categoric. Numeric factors are those factors which assumes the numerical values and they are continuous throughout the response surface. While categoric factors are, they can be either present or absent. So they are called categoric factors. But normally we are not dealing with the categoric factors. We in majority of cases we deal with the numeric factors. Okay. So there are three factors. Let us name them. Factor one is oil. Okay, no, over here it cannot be. So factor one is suppose disintegrating agent, factor B is binder, and C is the lubricant. These are the three factors which I have placed. And lower range and higher range is -1 and +1. Alpha values will be calculated by itself. Now, uh, we need to prepare full design. Here there is an option for blocks. How many blocks you want in your design, whether you want to perform all the experiments in a single block or you want two blocks or three blocks. So accordingly you can select. At present we are only dealing with the single block, so I'm not selecting anything over here. Okay, then total number of runs required are 14 and 6 center points. I can change the values of the center points. Say I'm only willing to incorporate one center point. I'm not willing to replicate the center points. Then alpha value. Whether you want rotatable design, then alpha value is 1.68. If you want face centered, the alpha value will become 1, as we have discussed in the last lecture. Okay, so if you take face centered, it will automatically consider alpha is equal to 1. If you want rotatable, that is these circumscribed design, it will consider alpha as 1.68. And if you want other, then it considers you can put the value. Okay, so total 17 experiments will be performed over here. Okay, 15 experiments will be performed over here. So when you press next, you need to introduce response. How many response you want? At present, let us go with the two response. One response, that is disintegration time, and second response, that is the hardness or crushing strength. Okay, these are my response. And the units I'm not mentioning. Say dt is in seconds for an example, and the crushing strength is in newtons per meter square or kp, kilopounds. Now the design expert will construct the design for me. Now as you can observe from this, the runs are totally random. Okay, they are not according to standard order. So first column shows the standard order, second shows the run, which experiment is to be performed first. Now we can arrange them according to standard order. So sort by standard order. So it will arrange the experiments by standard order. We can input the values. Say I'm randomly putting the values of the disintegration time. Okay, they are randomly placed. Similarly, for crushing strength also, I am randomly placing the values like 5, 6, 7, 8, 6, 7, 8, 6, 9, 7, 8. These are totally random, so significance may not be observed over here, but still for understanding purpose. Next thing is evaluation. So once we construct the design and we input the response after performing the experiments, we are getting the values of the response. Once we input the response, check the status. It is okay. Then go for the evaluations, result, and graphs. This is the graph of a design. Then analyze the individual response. So it will provide you the fit summary. Now, from the fit summary, it suggests that the mean only model is suggested. That is, your response is not dependent on your factors. Your factors are not having any significant effect on your response. So it suggests linear model. Okay, because it is having highest degree of highest f value or sum of squares. Rest of all in cubic it shows aliased. Aliased means your number of experiments are not sufficient enough to determine the relationship with confidence. So another alternative, for an example, I'm selecting two-factor interactive. Okay, or I can select cubic, in which the probability is very high, so it is not suggested. But still, say I select quadratic. So from this also I can change the equation is two-factor interactive, for an example. So it will show the values of all the two-factor interactions. Then ANOVA. If I'm selecting two-factor interactive, the ANOVA output will be showing the results, and it shows that probability is very high. So it is not significant. The model is not significant for the disintegration time. That is, relationship is not proper, and equation will be shown at the end. The disintegration time is equal to plus 54.60 minus 1.49a, etc. Okay. Now again, we can get the graph. This is the counter plot. Counter plot is nothing but the lines of the response lines where the response is equal. When we change factor x1 and x2, the response changes. But there are some points where we are getting equal response for different combinations of x1 and x2. So these lines suggest those equal combinations. Okay. Then for crushing strength, let us analyze. It shows linear relationship is suggested. So model, what is suggested, we take it. The ANOVA, it shows probability 0.07. Though it is greater than 0.5 and not significant, we accept it. And over here, we will find out the relationship between the independent variable and dependent variable. So crushing strength is equal to 7.33, that is B0 plus 0.42 multiplied by A plus 0.71 multiplied by B plus 0.17 multiplied by C. And again, you can get the model graph. Okay, so these graphs are obtained. Till this, after analyzing only, we can go for the optimization. Actually, whenever we are conducting any experiment, the purpose is to find optimum. That is optimization. That is the ultimate goal. So for optimization, we can go for either numeric optimization or graphical optimization. We can go for point prediction as well. But in point prediction, we are getting the idea about the response at a particular point. Now, after analyzing the response, we can go for optimization. So which things you want to optimize? For an example, your DT, it should be minimum or maximum. Disintegrant concentration, binder concentration, and lubricant concentration. These are our factors. So we normally don't change them. The response disintegration time, we want it to be minimum. And crushing strength, we want to be maximum. Actually, there are four options possible over here. You can either minimize or maximize, or you can get set in a target that it should be exactly 50 seconds, or it should be in a range that it should range between 45 to 55 seconds. So you can set any value and you can input upper and lower limits. So your crushing strength should be maximum and dt should be minimum. When you analyze it, it will give the idea of dt 49 and crushing strength 8.28, and the desirability of that is 0.718. Now let me explain what is desirability. Desirability is term that is used that what we desire, we want in our response, what kind of response we are willing to obtain. That is our desired response. Say, again taking the previous example, if I'm willing to purchase a car, my desired car should have very good mileage of 30 kilometers per liter. It should have a very good safety features, that is 5 airbags, etc. etc. It should have good look, elegant look. It should be SUV and it should cost around 10 lakhs. So all these things are desired, but practically it is not possible sometimes to obtain all these features in a single car. So accordingly, we can rate the car from 0 to 1 of my desirability. That if the cost is 10 lakhs, then it is least desired. If it is 8 lakhs, it is most desired. So if cost is 10 lakhs, I will assign it value desirability value 0. If it is 8 lakhs, I will assign the value of desirability 1. And accordingly, rest of the values will be assigned the desirability. Say 9 lakhs, it is a desirability of 0.5. Then 8.5 lakhs, 0.75. 9.5 lakhs, that is 0.25, and so on. Similarly, for all experiments, we can assign the desirability. So I will get the desirability for each of my attributes or response. Here I have two response, that is disintegration time and crushing strength. The desirability which is obtained over here is a composite desirability. That is nothing but the geometric mean of the individual desirabilities that are calculated by predicting the response. Okay, and the design expert will suggest you the batch with maximum composite desirability. Okay? It will suggest you the batch with maximum composite desirability. Ideally, it should be as close as possible to 1, but practically we may get, if we get about 9, 0.9, then also it is acceptable. Okay, and this is the graph of the desirability. As this graph show that as the disintegrant concentration increases, the desirability increases. Similarly, as the binder concentration increases, the desirability increases. Okay, and third factor is kept constant over here. Our third factor is kept constant over here. Clear? This is the prediction. 0.7. These are 3 batches which are suggested by the software to be prepared. Okay, the flag. Here the prediction 0.72 is my flag. So this flag batch I need to prepare. Now if I double click on this flag, I will get the value of x and y which I need to use. So x should be used at 0.98, y should be used at 1, and lubricant concentration is kept constant at -1. It is shown over here. So I can utilize this. I can prepare a batch and then we can go for the checking whether the relationship is properly followed or not. Okay. Next is graphical optimization, in which the graphs are produced which overlay, that is dependent on the equation which we have derived. At present, none of our equations are fully empowered to explain the relationship between independent and dependent variables. So we are not getting proper results. And point prediction, in which we can predict the point. Here are the settings for factors. Say I'm keeping A is at this level, B at this level, and C at this level. So I can get the prediction. What will be the value of my response? Disintegration time will be 54 and crushing strength will be 7.33. If you look at them closely, if I'm changing this, the values of response changes. when I'm adjusting the response, the values changes. Okay, so that is point prediction. At a particular point, what will be the response that can be predicted using software. Clear?